Good morning, Yugant. Okay, students. All right. So, a very good morning to all of y'all. We have again gathered here to continue with our quadrilaterals revision. So, those who are new today, I hope that you're already well aware of all the properties of the quadrilaterals that we have. So, we have what are the different kinds of quadrilaterals that we have already seen, people? Yes, we have seen the parallelogram. Yeah. So we have already seen the parallelogram. Then was the rectangle. Yes. Next one was rhombus. Then we saw the square. What else, students? Trapezium and kite. Yes, so these were the 6 kinds of quadrilaterals that we have studied that are there in your syllabus, people. And I hope that you have revised all the properties, like I had told you all, because these properties are extremely important for you all to understand the rest of the sums. All right. Okay. So let's begin with the next sum. We had just seen one sum from our syllabus. Let's go ahead with other sums today. Also, as we move ahead, we're going to revise each and every property of every figure that we have studied. All right. So let's look at the next question. Show that diagonals of a square. So diagonals of a square. It's already known to us that ABCD is a square. All right, students. So whenever you get any sum, especially sums which you need to prove, the moment something is given to you, please mark that in your figure. Or if the figure is not given to you, please draw a rough figure and mark the necessary things that you know about it. So the moment you know it's a square, what do we know about a square? Yes, all sides of a square are equal. So I'm going to mark all sides of a square equal. Also, what else do we know? Every angle of a square is a right angle. Yes, a square is a proper mixture of, you can say, a rectangle and a rhombus. So you can say every square is a rectangle, every square is also a rhombus, right? So those are the properties of a square. Now let's see, what do we have to do with this square now? We need to show that diagonals of the square are equal. So basically, diagonals we know are definitely AC and BD. So first thing you need to prove is that these two diagonals are congruent. Okay, so we need two sides equal. And what else? Also, they bisect each other at right angles. Now, students, the moment we move to the second part of the question, diagonals need to bisect. Yes, now diagonal AC, if you check, bisect means two equal parts, right? So AC is getting cut into which two equal parts? AO and OC. We need to show that AO is equal to OC. BD is getting cut into which two equal parts? That is BO and OD. Yes, BO and OD. So we show that BO and OD are also equal. So does it stop here? There's another thing, a third thing. Diagonals bisect each other at right angles. We need to show that one of these angles, either angle AOD or angle COD or angle BOC or angle AOB, each of them should be equal to 90 degrees. So we just need to prove one of the angles is 90. Yes, the rest will be taken care of because these two are vertically opposite angles. So if one is 90, the other has to be 90. Also, the adjacent angles are angles in a linear pair. That's how we know if one angle around a point is 90, all the remaining three angles have to be 90 degrees, right? So these are the 4 things that we need to prove. Now let's start looking at the first thing. Okay, one by one, we're going to look at each of the things. Now, students, AC and BD. Yes, AC and BD are just two sides of two triangles. So if we need two sides congruent, can I just say that I need to prove two triangles congruent? Yes, look at AC and BD. They belong to which two triangles? I can say AC belongs to triangle ACB. Yes, AC belongs to triangle ACB and BD belongs to triangle ABD. Come on, students, quickly, I'm going to highlight these two triangles for y'all, ACB and ABD. Yes, and quickly, y'all need to tell me how these two triangles are congruent. Come on, students, quick. Triangle ABD and triangle ABC. So I'm going to give you all the names again. ABD and ABC. Quickly, I want you all to type in the chat box how these triangles are congruent. Come on, students, those who are joined. Quickly tell me how the triangles are congruent to each other. Okay, Yugan says SAS test. All right. Okay. Yes, Yugan, that's correct. Anyone else? Yes, Tanisha, Srishti. Which test? Only SAS test? Is there any other test? Come on, let's try to see. Let's try to see which test we have out here. So what do we know? AD and BC. Yes, AD and BC, which are the opposite sides, are sides of a triangle and they are congruent to each other. Yes, definitely. What else do we have? We have AB equal to AB. AB becomes the common side. And we have angle A equal to angle B. Students, for simplicity, I have written the angle using single letter. Make sure you always name angles using three letters so that there is no ambiguity. Yes, so what do we have? We have a side, we have an angle, and we have another side. So by SAS test, the two triangles are congruent to each other. Yes, by SAS test, the two triangles are congruent to each other. Now, since the two triangles are congruent, can I safely say corresponding sides of congruent triangles are equal? Yes, AC and BD are equal by CSCT, or you can always write CPCT for corresponding parts of congruent triangles. Yes, CSCT or CPCT. So students, pay attention. The first part that we had to do is done. Now look at OA equal to OC and OB equal to OD. We're going to solve the second part simultaneously with OA and OB. Students, pay attention. OA and OC, two sides are supposed to be equal. Can I say OA belongs to triangle OAB and OC belongs to triangle OCD? Yes, we can clearly see that. Similarly, OB belongs to triangle OAB again and OD belongs to OCD again. So if I just prove these two triangles congruent, 1 and 2. If I prove these two triangles congruent, can I directly say OA equal to OC and OB equal to OD? Yes, definitely. Proving these two triangles is going to give me by CPCT or CSCT OA equal to OC, OB equal to OD. So let's quickly look at these two triangles now and kindly tell me by which test do you think they can be congruent? Come on. I would like you all to type that in the chat box. I've already numbered the two triangles for y'all. So let me know by which test you think these two triangles can be congruent now. And students, make sure you do not use what you need to prove as a part for your criterion. Yes, do not say OA equal to OC or OB equal to OD. That is something you need to prove. Okay, let's quickly try to see what we have. Now, students, pay attention. First, let's move towards the ASA. Yugan says ASA. All right, Yugan, can you quickly point out which are the two angles that you're talking about? So Yugan says ASA. Let's quickly see which are the two angles that we're looking at. DCO. So we have DCO, this angle, and OAB. Okay, all right. And which is the other angle? Come on, others. I hope you guys are not happily gone in your dreamlands, people. Come on, I expect you all to type something as well. Yes, that's very good, Yugant. Which other angle are you looking at? AOB. Okay, AOB and COD. All right, this angle. And Bacha, what's the side you're looking at? Which side are you looking at then? These two angles are definitely correct. The pairs of angles are correct. And the side is AB and DC. Yes, that's correct. But there's one small problem. Yes, you identified the angles correctly. So Yugan says that angle DCO is equal to OAB. First of all of y'all who have not understood why DCO and OAB are equal, before that, let's move to the obvious things. This is a square. Yes, we all know this is a square. So all the sides are equal to each other. So definitely AB and CD, which are the opposite sides, have to be equal to each other. This is a very obvious observation. What's the next observation? Angle AOB and angle COD. Yes, again, extremely easy. These two are a pair of vertically opposite angles. So two things were easy. But what about the third thing? Now, students, pay attention. Going back to the basics. Every square is a rectangle. Every square is a rhombus. And every square is also a parallelogram. Yes, every square is a parallelogram. So moment you realize this is a parallelogram, can I say CD is parallel to AB? Yes, definitely. CD is parallel to AB. And look at transversal AC. If you look at transversal AC, what do we have? We have a Z being formed and we have a pair of alternate angles. I'm marking those alternate angles for you all. Students, pay attention. We have a Z letter being formed, and angle DCO and angle OAB are a pair of alternate angles. So let me write them for you. DCO and OAB. Yes, DCO and OAB are a pair of alternate angles, and as you know, alternate angles are equal. So you identified the all the steps very nicely, but there's one small problem. Look at the test that you're using. What do we have? We have a side, yes, CD. We have this angle C, so we have side angle angle. It is the SAA test. Yes, it cannot be the ASA test because for ASA test, students, the side has to be in between the two angles. But what do you observe? The side is coming first, then an angle, and then the next angle. So by SAA test, these two triangles are congruent. First of all, yes, anyone has any issue with this explanation? Anyone who has not understood why the triangles are congruent by SAA test or anything to do with the alternate angles? Let me know first. Anyone, any issue? Otherwise, we'll be moving ahead. Okay, so I believe there isn't any issue. So now students, pay attention. So we saw that the two triangles are congruent by SAA test, but let us see if they are also congruent by the ASA test. Yes, students, let's see if the triangles are also congruent by the ASA test. It is possible that the triangles can be congruent by more than one test, or you will be able to apply more than one test to it. Now let's look at ASA. First of all, what are the angles and sides that we had seen? Let's take this side constant. Yes, DC congruent to AB. We also saw that angle DCO is congruent to angle OAB on transversal AC, right? Let's look at the other thing. We know that DC is parallel to AB. We already saw transversal AC. What about transversal BD? Yes, look at transversal BD. Do we have another Z being formed? Students, pay attention. There's an ulta Z being formed, right? And what about these angles? Angle CDO and angle OBA. Yes, students, angle CDO and angle OBA is the second pair of alternate angles. So if you use these two angles, then definitely you can say that the two triangles are congruent by ASA test. Yes, so if you use two alternate angles, we can use the ASA test. And if you use one alternate angle and one vertically opposite angle, then the triangles are congruent by SAA test. I hope this is understood. You can go with whatever is convenient to you all. There's no hard fast rule. You just need to prove the triangles congruent by a particular test which is there in your syllabus. Out of the 5 tests, you can use any of the tests. So I hope this is clear to you all. Now it's very evident that the two triangles are congruent. Yes, these two triangles are congruent. Let's see what test they have used. Okay, so they have used the ASA criterion. Yes, they have used the two alternate angles, but we all know we could always use these vertically opposite angles and say that the triangles are congruent by the SAA test. Yes, you don't have an AAA test. Otherwise, we could have used that, but there's no AA test. All right. So you cannot use angle, angle, angle test. Okay. So now since the two triangles are congruent, students, look at their corresponding sides. What did we need? We needed OA, right? It's high time you identify the corresponding sides from the triangle congruency. So OA corresponds to, yes, students, OA corresponds to OC. So pay attention. OA corresponds to OC. Yes. So we have AO congruent to CO. What else? We needed OB congruent to OD. So look at this. OB is congruent to OD. So pay attention, students. This congruency that you write between triangles has to be according to the correct correspondence. You cannot say that AOB is congruent to triangle DOC. No, that is not possible. This is wrong. You will get 0 marks for this, even though the triangle names are same, but correspondence matters the most when using this symbol sign. Yes, when you use this symbol, you have to write the correct order of correspondence. If AO corresponds to OC, you cannot write AO with DO. I hope you all have understood this. So let's move ahead. So quickly we can say OA equal to OC, OB equal to OD by CPCT or CSCT. So we're done with 3 things. The last thing, AC perpendicular to BD. Now students, pay attention. Let's look at this thing, AC perpendicular to BD. So what do we need? We need the two diagonals to intersect each other at right angles. And students, this property belongs to specifically which quadrilateral? Diagonals bisect each other at right angles. Apart from square, this property belongs to which other quadrilateral? There's just one more quadrilateral where the diagonals are perpendicular bisectors of each other. Yes, students, come on. I would like you all to type in the chat box. Let me see if you've done your homework well. Come on. This property, diagonals bisect at right angles, belongs to which other quadrilateral apart from square? All right, come on, students. So no one's done their homework, that means. Okay, Tanisha says rhombus. All right, anyone else? So Tanisha, that's perfectly correct. Okay, I see someone typing. Yes, so definitely another quadrilateral which shares this property is definitely the rhombus. Only for a rhombus, diagonals bisect at right angles. And like I said, yes, Meghna, that's perfectly correct. Thank you so much. Yeah. So only for a rhombus, diagonals bisect at right angles. And like I said, a square or every square is a rhombus. Every square has to use this property of the rhombus. So now let's quickly move towards how we are going to prove that AC and BD are perpendicular to each other. So students, like I said, for AC and BD to be perpendicular to each other, we need angle AOD and angle DOC each to be 90 degrees. Yes, perpendicular lines means we have an angle of 90 degrees between those lines. Now students, whenever you need a 90-degree angle as well, you need to prove two triangles congruent. But these two triangles should be adjacent triangles. Now, why do I say we need the two triangles congruent? And why should they be adjacent? Because pay attention, students. Look at this red and blue triangle. If I prove these two triangles congruent, we move to that later how we will prove them congruent. But look at them. If I prove them congruent, what am I going to get? Angle AOD congruent to angle COD. Yes, I'm going to get AOD and COD congruent to each other. Now, once these angles are congruent, we also know that AOD plus COD is equal to 180 degrees. Why? Because they are angles in a linear pair. Yes, AOD and COD together it's 180. But since they are equal to each other, can I say x plus x is equal to 180? Since both the angles are equal to each other, I've just given them a letter x. So if 2x is equal to 180, we know that definitely x is going to be equal to 90 degrees. Yes, x is 90 degrees, and that's how we are going to get that AOD and COD each will be 90 degrees. So that is why, students, whenever you have to prove any two segments perpendicular to each other, or if you want a given angle to be 90 degrees, take two triangles, prove them congruent, and make sure that the angles are a linear pair of each other. Yes, all right. So let's quickly move towards that now. So students, you've already seen these two triangles and it's extremely easy to prove. Now, pay attention. Sides of a square are equal to each other. So we have AD and CD equal. We have D, let's call this O. So we have DO as the common side. And we had just proved, right? AO and OC are equal to each other. So we can always use this part. And what do we see? By SSS test, these two triangles are congruent to each other. Now, like we had seen, once the two triangles are congruent, I can definitely say AOD is congruent to COD. You can either give them a letter X and X or just use it the same way. But we also know they are angles in a linear pair. So I have quickly replaced COD with AOD. Twice AOD is 180, so we can see AOD is 90 degrees. What we get is this angle is a right angle, and hence AC and BD are perpendicular to each other. Okay, students, any issues with this sum? Anywhere in any of the parts? We have just proved all the four parts using congruency of triangles. So you can see how important is your triangles chapter. Yes, congruency is an extremely important property, which I'm sure you must have studied well by now. Okay, so anyone, any issues with this sum? Else we can move ahead. All right, no, okay. Others, come on, quick. Students, at any point of time, if you feel that something is going fast, or if you feel some property or some concept is not understood well by you, please stop me then and there and we'll just go through it once again. So let me quickly see if anyone has any issues. Okay. People, come on, let's make this interactive. I mean, it's going to be so boring for me if I'm going to be the only one talking. Okay, Gandhar, thank you so much. All right. Okay, so I believe there's no problem. We can quickly move to the next sum. Okay, so we're going to move to the next sum. All right. Now, let's see what this sum talks about. Diagonal AC of a parallelogram ABCD bisects angle A. So students, quickly what we understand is we have a parallelogram given to us out here. So we see a parallelogram out here, and it's also given that this diagonal AC bisects angle A. So quickly, as you can see, angle DAC. Okay, thank you so much, Meghna. And angle BAC. These two angles, DAC and BAC, are equal to each other. All right, students, I would always prefer that if two angles are equal, you better give them the name as X. Okay, so let's quickly look at this sum. We have diagonal AC and this is a parallelogram. Now, important properties of a parallelogram. Let's quickly revise them. We know that opposite sides of a parallelogram are equal to each other. Only opposite sides are equal. So AB and CD equal to each other. AD and BC equal to each other. Yes, so I have marked that. What else do we know? We also know that opposite sides of a parallelogram are parallel to each other. Students, this is a sign for parallelism. So I've quickly marked the signs for parallelism out here. Yes, so that we can quickly see that opposite sides are parallel and equal to each other. Now let's quickly move with the sum. So what do they want? They want that diagonal AC also bisects angle C. We need to show, so I'm quickly gonna mark that with a different color. Okay, so what we need to show is these two angles equal. Yes, I have marked this with red, whatever all angles are equal. No, Swaraj, that's not correct. What do we know about angles of a parallelogram? All angles are not equal. Yes, angles of a parallelogram. What do we know about them? Adjacent angles are supplementary. That's correct. And what do we know about opposite angles of a parallelogram? That's perfectly correct, Yugan. Thank you so much. What about opposite angles of a parallelogram, people? Come on, everyone. Yes, let me see who all are sleeping. Tanisha, Meghna, Swaraj. Yes, what do we know about opposite angles? Yes, students, opposite angles of a parallelogram are? Yes, okay, people have not done their homework well. That means students, opposite angles. Yes, that's correct. Opposite angles of a parallelogram are equal. That means angle A and angle C are equal. Angle B and angle D are equal. All angles are not equal. All angles are equal only in a rectangle and only in a square, where all angles are equal and 90. We already know that. Yes, so students, pay attention. Since all angles are not equal to each other, what we need to prove is that angle C is getting bisected by angle by AC. So students, pay attention. What we need to prove is angle DCA equal to angle BCA. This is what we need to prove. We need to prove that DCA equal to BCA. Now students, let's quickly start with what we already know. All right. So what do we know? It's given that DAC and BAC are equal to each other. Yes, that is given to us because angle A is getting bisected by AC. All right. Now let's see what else we can do, students. Pay attention. Since we know that opposite sides of a parallelogram are parallel, now we are going to look at some pair of adjacent angles. Students, look at AD and BC. It says AD and BC are parallel to each other. And look at transversal AC. We are going to look at transversal AC. So what do we see? Come on, pay attention. I'm going to move this. So we have AD parallel to BC, AC as the transversal. So what about angle DAC and angle ACB? Students, pay attention. Look at angle DAC and angle ACB. Yes, what do they form? They form a pair of alternate angles. DAC and ACB form a pair of alternate angles, so they are equal. So I'd already named these two angles as X and X. Now, since DAC is equal to ACB, I'm going to name this as X as well. Now, students, pay attention. If I get this angle also equal to X, is my work done? Yes, angle C is going to be bisected, right? So pay attention. Similarly, now students, pay attention. What do we have? Look at angle BAC and angle DCA. So now we are going to look at this Z. Students, pay attention. DC and AB are parallel to each other, and on the same transversal AC, we have another Z being formed. Yes, we have another Z being formed, and I'm going to mark these two angles with a different color. So let me see. Okay. All right. So this angle and this angle also form a pair of adjacent angles. So can I say this angle is also X? Yes, definitely. Now students, what do you see? Angle DCA and angle ACB both are equal to X. Yes, DCA and ACB both are equal to X. So can I say angle C is getting bisected? Definitely. Since both the angles are equal, angle C is getting divided into two equal parts. And so I can say that angle C is also bisected by AC. Anyone, any issues with the first part of the sum? I'm going to quickly take you all through the steps, but anyone has any issues with how we can solve this sum? Okay, no, all right, okay. So students, let's move ahead. Let's quickly move ahead to the second part. Before that, anyone who feels, ma'am, we could, since we need two angles equal, we could also solve this using congruency of triangles? Yes, we could, right? We can always solve this using triangle congruency. If you need two angles equal or if you need two sides equal, students, always those sums can be solved using congruency of triangles. Let's quickly see if we can do that using congruency. Yes, what do we have? CD and AB as opposite sides of the triangle. Students, I'm going to look at triangle. Okay, let me quickly name the two triangles that we're going to prove congruent. It's going to be triangle ADC and triangle ABC. We are going to prove these two triangles congruent. Let's quickly look at that. Can I say DC congruent to AB? Yes, opposite sides of a parallelogram. Also, AD congruent to BC, again opposite sides of a parallelogram, and AC congruent to AC. Yes, common side. So by SSS test, the two triangles are congruent, and we can also get these two angles congruent by CACT. Yes, CACT or CPCT, corresponding angles of congruent triangles. Yes, students, so we could use that as well. But since we already have parallel lines, we have used the property of alternate angles. So as you can see, we have used the property of alternate angles. We have two alternate angles out here. But since, observe 2 and 3, since DAC is equal to DCA, I can safely say BAC and BCA are equal to each other. Yes, BAC and BCA are equal to each other. Hence, we got these two angles congruent. Okay, now let's move to the next thing. We need to show that ABCD is a rhombus. Students, pay attention. We already know that ABCD is a parallelogram. Now we need to show that ABCD is a rhombus. For that, from parallelogram to rhombus, students, if we need to prove that, you need to remember the properties of a rhombus. Quickly tell me, what is the most important property of a rhombus, or what's the definition of a rhombus? What is that one particular thing that a rhombus has which a parallelogram does not have? How do we understand that the given quadrilateral is a rhombus? Okay, Meghna, yes, that's perfectly correct. When all sides of a quadrilateral are equal, only then we can say that it's a rhombus, right? But what do we know out here? Since this is a parallelogram, we already know that opposite sides are equal. So students, if somehow, okay, diagonals of a rhombus are perpendicular to each other, yes, Tanisha, that's correct. But the definition of a rhombus that all sides are equal. Yes, so this is a very simple thing to prove. So in this, we are just going to prove all sides equal and we'll be done. The parallelogram will be ready to become a rhombus now. So students, pay attention. We already know that opposite sides are equal. Yes, so if somehow, now pay attention, if somehow I get AD equal to CD, if somehow I get AD and CD congruent to each other, then since AD is congruent to BC, even BC will be congruent to CD. Yes, and we already know that CD is congruent to AB, so CD is congruent to AB and BC is congruent to AD. And hence, if I just get AD equal to CD, all the four sides are going to be equal. Yes, definitely. So if I just get two adjacent sides equal of a parallelogram, then I can safely say that all sides are equal. So we are not going to waste our time doing this. We won't waste our time proving all sides equal to every other side. We just need to get one pair of adjacent sides equal. Students, again, what's the meaning of adjacent? Adjacent means next to each other. Yes, so you could have a question, ma'am, we could also prove AB and BC equal to each other since they are adjacent sides. Definitely. You could do that as well, but I'm going to choose this. So you could either prove this or this. One pair of adjacent sides equal to each other. All right, so let's quickly look at AD and CD. Now, students, so we're going to quickly look at AD and CD. Now, AD and CD are two sides of a triangle. Yes, AD and CD both belong to which triangle? They belong to triangle ADC. So let's look at triangle ADC. In triangle ADC, what do we observe? We know that angle A is X, yes, and so was angle C. Yes, only in triangle ADC, we already saw that angle DAC and angle DCA both are equal to X, or both are basically congruent to each other. So can I say that two angles of a triangle are equal? Now students, we have an extremely important theorem related to two angles equal in a triangle. Anyone, what is that theorem? What do we know when two angles of a triangle are equal? What do we know about two sides of that triangle? Come on, students, quick. Time to get the basics in again. What do we know about two sides of a triangle if two base angles of the triangle are equal? Yes? Which theorem can I apply out here? Yes, students, we have two angles equal. So what do we know about two opposite sides of that triangle? Come on, students. Have you all forgotten the isosceles triangle theorem? Yes, if two angles are equal, sides opposite to equal angles are also equal. Look at angle DAC. Angle DAC has which side opposite to it? It is side DC. Look at angle DCA. DCA has side AD opposite to it. So can I say since angles are equal, sides opposite to them are also equal to each other? Yes, definitely. AD and CD are sides opposite to equal angles. So they are equal to each other. Okay, before we move ahead, I'd like to know how many of y'all haven't understood this. Why AD and CD are congruent to each other? Yes, students, come on, quick. Anyone who has not understood why AD and CD are congruent to each other? Yes, students, come on. Okay, so I assume you all have understood this part well. So pay attention, students. Now, since the two angles are congruent to each other, I can say AD is equal to DC. We have already seen that. And since now AD and DC become equal to each other, a pair of adjacent sides of a parallelogram are equal. So I can safely say it's a rhombus. Because if AD is equal to CD, we also know that AD is equal to BC. We also know that CD is equal to AB, and hence all sides will become equal to each other. Students, this reason is extremely important. This is kind of a definition. A parallelogram becomes a rhombus if a pair of adjacent sides is equal. If even one pair of adjacent sides like AD and DC, or AD and AB, or AB and BC, or BC and CD, any pair of adjacent sides, if they are congruent to each other, then definitely the parallelogram becomes a rhombus. All right. Okay, students. So let's quickly move to the next sum. So we're going to quickly look at the next sum now. Okay. This is an extremely easy sum and I'll expect some answers from you. ABCD is a parallelogram. Quick. Okay, so we have opposite sides equal and opposite sides parallel to each other. Okay, I'm not going to mark the remaining two sides because we don't want them right now. What else do we have? And AP and CQ are perpendiculars from vertices A and C. So we have AP perpendicular to BD and CQ perpendicular to the same side BD. Now quickly, students, look at the first part. I already said this is an extremely easy sum. So quickly tell me, how are triangles APB and CQD congruent to each other? It's already given for y'all. They are highlighted for y'all. Quickly observe, how are APB and CQD congruent to each other? Quickly let me know the name of the test. And we've been doing this since a very long time. So come on, quick. APB and CQD. How are these two triangles congruent? Okay, all right, students, pay attention. This was an extremely easy one. Let's look at it. What do we have? We have CD congruent to AB. Yes, CD and AB are opposite sides of a parallelogram. Okay, Yugan says SAA. All right, Yugan, that's perfectly correct. By SAA test, they are congruent to each other. Pay attention. CD and AB are congruent to each other, opposite sides of a parallelogram. Now, what else do you see? It's already given out here about the alternate angles. CD parallel to AB on transversal BD. What do we have? We have a Z being formed. Angle CDB is congruent to angle DBA. Yes, CDB congruent to ABD. There's a letter Z being formed. So we have a pair of alternate interior angles. And what else? It was already given, right, that we have a pair of right angles. AP perpendicular to BD, CQ perpendicular to BD. So we have a pair of right angles. By SAA test, the two triangles are congruent to each other. So let's quickly see. Since the triangles are congruent to each other, students, look at AP and CQ. Do AP and CQ belong to these triangles? Let's quickly see. So AP belongs to the first triangle. Yes, AP belongs to the first triangle and AP corresponds to CQ. So AP and CQ are definitely equal to each other by CPCT or CSCT. These two triangles are, these two sides are equal to each other because they are corresponding parts of congruent triangles. Yes, students? All right, let's quickly move to the next sum since this was an extremely easy one. All right. Okay. Now let's look at this sum. Since if you feel any sum is easy, when you look at it, you can quickly tell me. I can skip that sum if all of you feel it's pretty easy to go about. Okay. Let's quickly move to the next sum now. In parallelogram ABCD, 2 points P and Q are taken on diagonal BD. So we have diagonal BD and P and Q are just two random points on that diagonal. Next, such that DP. Students, pay attention. What is given? DP is equal to BQ. So I've marked that for you. DP and BQ are equal to each other. Let's move one by one. There are 5 steps for this sum. Let's move to the first sum. We need to show triangle APD congruent to triangle BQC. Let's quickly highlight them for you. So we want APD congruent to BQC. As you can see, everything is marked for y'all. Opposite sides of a parallelogram are equal. So AD equal to BC. Now students, whenever you have parallel lines, there is always a possibility of alternate angles or corresponding angles or interior angles. Keep your eyes open for such angles. And here we have a pair of alternate angles. Angle ADP is equal to angle CBQ. Pay attention to these two angles. Yes, they are angles within the letter Z and they are a pair of congruent angles. All right. And what else do we have? DP and BQ equal to each other. That was given to us, right? DP and BQ equal to each other. So what do we know? Since we have already got the 3 criterion, the 2 triangles are congruent by SAS test. Yes, by which test, students? By SAS test, the 2 triangles are congruent. Now quickly look at the next part. AP equal to CQ. It's just like the previous sum. AP and CQ are nothing but the sides of these 2 congruent triangles. They have to be congruent to each other. Yes, by CPCT, CSCT, you can write whatever suits you all. So these 2 are done by proving these 2 triangles congruent, APD and BQC. Now look at AQB congruent to CBD. The third part. We want AQB and CPD congruent. Come on. Quickly observe, students. Look at AQB. So this triangle and CPD, which is this triangle. Quickly now, I want you all to tell me how these triangles can be proven to be congruent. Come on, students. We've already seen the first part. Now it's just on the same lines. Okay. Yugan says SAS. All right. Others? Yugan, meanwhile, can you let me know which angle are you talking about? Which is that pair of angles which are equal? Okay. CDP and ABQ. Let's quickly look at these 2 angles. CDP and APQ. Okay, let me check them. Okay, so you're talking about this angle and ABQ, which is this angle. Yes, Meghna, that's perfectly correct. All right, yes, SAS test. Thank you so much, Yugant and Meghna. That's correct. Students, now pay attention. AB and CD are parallel to each other, and on transversal BD, there are a pair of alternate angles being formed, ABQ and CDP. The same way, they are alternate interior angles, so the angles are equal. Next, BQ and PD, again, They are the given sides. So by SAS test, again, these two triangles are congruent. And look at the fourth part, AQ and CP. Students, AQ belongs to the first triangle that we just proved, and CP is the corresponding side in the second triangle. So definitely AQ and CP have to be congruent to each other, because corresponding sides of congruent triangles are equal. Yes, AP and CQ are equal to each other. All right. Okay, students. Yes, all right. Thank you so much, Gandhar. That's perfectly correct. Let's move to the last part. So we have proved the first four parts. Now we need APCQ to be a parallelogram. Now, students, with these existing four parts and using properties of parallelogram, let's see what can be used. Quickly, I'm going to brush all the properties of a parallelogram, starting with the most important property or the most important definition. What's a definition of a parallelogram? Opposite sides of a parallelogram are equal. The name itself, right? The name itself, parallelogram, suggests parallel sides. So opposite sides of a parallelogram are equal. Okay, so all right. But if you look at APCQ, APCQ, do we know anything about opposite sides of this figure? Do we know anything if the sides are parallel? No. So this property is ruled out. What's the second property? Okay, Swaraj says two pairs of sides are equal. Yes, that's correct. Now, let's look at the second property. Opposite sides of a parallelogram are also equal to each other, students. Opposite sides are also equal to each other. Let's look at the opposite sides. What do we know about the opposite sides in this parallelogram? AP and CQ are the opposite sides, and AQ and CP are the next pair of opposite sides. Do we know anything about the lengths of these two sides? Yes, okay. Yes, students, pay attention. Look at the second part and the fourth part. The second part says AP is equal to CQ. The fourth part that you proved says AQ is equal to CP. And isn't that the property of a parallelogram? Opposite sides equal. So using this property, yes, you don't need to prove anything now. You can just say from 2 and 4, or wherever you had written that, from 1 and 2, you can just say that since opposite sides are equal, APCQ is a parallelogram. And don't forget to mention that a quadrilateral in which opposite sides are equal is a parallelogram. Always, whenever you say that a quadrilateral becomes a parallelogram or a parallelogram becomes a rhombus, make sure you write by which property you have proved this. Yes, so the property we have used here is opposite sides of a quadrilateral are equal, then it has to be a parallelogram. Yes, so this property of a parallelogram is being used out here. Okay, so I hope you have understood all these 5 parts well. Any issue with any of this, students, you can always type your type your question in the chat box, or you can always raise the hand as well. You have a raise the hand option, which you can always use. All right, so quickly we are going to look at the next question now. Okay, now quickly let's look at this next question. ABCD is a trapezium in which AB parallel to CD. Students, now we have seen a trapezium is a slightly different figure than a parallelogram, rectangle, rhombus, square. Yes, how is it different? A trapezium has only one pair of parallel sides. So it has only one pair of parallel sides, and here it is given AB and CD are parallel to each other. So what about the non-parallel sides? In a regular trapezium, we know nothing about the non-parallel sides. So let's have a look at them. They say AD and BC. Students, pay attention. In a trapezium, we have one pair of parallel sides and one pair of non-parallel sides. AD and BC are the non-parallel sides. And what have they given about those two sides? AD and BC are equal to each other. So we have already marked that AD and BC are equal to each other. Students, in a trapezium, when the two non-parallel sides are equal to each other, it becomes a special kind of a trapezium. Anyone, what is the name of such a trapezium? What's the name of this trapezium where we have AD and BC equal to each other? So we have AD and BC, which are the two non-parallel sides equal to each other. So there's a special name for this trapezium. And what is that name? Yes, okay, Swaraj says isosceles trapezium. Excellent, Swaraj. That's correct. This is an isosceles trapezium. And the word isosceles, you're already familiar with this, right? Isosceles triangle. You have already seen isosceles triangle in which two sides are equal. So the same way, this is an isosceles trapezium in which two sides are equal to each other. And which two sides, students? Only the non-parallel sides can be equal to each other. Yes, you'd never have AB and CD which are parallel to each other. They can never be equal in a trapezium. All right. Okay. So now we know this is an isosceles trapezium. But what do we need to prove? We need to prove C equal to D. We need to prove angle C and angle D equal to each other. All right, students. Now, extremely easy. I've always said whenever you need two angles equal or two sides equal, just prove two triangles equal. But we don't have two triangles, right? We don't have two triangles out here. So how do we get two triangles out here? Any ideas, students? How do I get two triangles in this trapezium? I need two triangles in which one triangle has angle C and one triangle has angle D. Any ideas, students? What do I do? Okay, diagonal. Which diagonal, Swaraj? Can you name the diagonal quickly? I'd like you to name the diagonal. Like, which diagonal can I draw? AC? Okay, Swaraj, let's see that. Okay, Yogan says diagonal AC. Let's do that for y'all. So I am going to draw diagonal AC. And what happens, students? Pay attention. We have angle D and angle ADC. But do we have angle C? No, angle C is being cut by diagonal AC. So do you think this is correct? Yes, diagonal AC. Do you think this is correct? Because it is cutting angle C, we cannot draw this AC, right? Because angle C is divided in both the triangles. So how are we going to prove D and C congruent to each other? Yes, students, have you all understood? So we cannot draw diagonal AC. Can we do anything else? Anything else so that we get two triangles which have angle C and angle D? First triangle should have only angle D. Another triangle should have only angle C. Any such ideas where we have only angle D and only angle C? Yes, students, come on. Anything else? Come on, quick. How else can I divide this? Draw CE through C. Okay, draw CE through C. Meghna, can you tell me also draw B? Okay, first of all, Meghna, can you tell me CE? E lies on which side? Yes, CE lies on which side? On AB, on AD? I'm not very sure. Swaraj says also draw BD. Okay, if I also draw BD, now even D is getting divided, right? Okay, BE. That's correct. Yes, Meghna, that's correct. Okay, Swaraj, please pay attention. Okay, Swaraj, if I draw BD as well, even angle D gets bisected now. I mean, I won't say it's getting bisected, but it's definitely getting divided into two parts. So students, in a trapezium, to obtain two triangles, drawing diagonal is never the best option. So let's see what we can do. Meghna, I'm not quite sure what you're saying. We draw BE onto BC. Not very sure. All right. Okay. Before we proceed, students, quickly, I would like you all to type if any one of you all belong to City International School, Aund or Wanavri. Yeah? City International School, Aund or Wanavri, you can type. And if not, you can type your branch name. Yeah? From which Mahesh Tutorials branch you are. All right. Okay. So students, like I was saying, in a trapezium, to get two triangles, drawing a diagonal is not always the best option because they are going to bisect the angles. So let's see what we are going to do. We are going to draw two perpendiculars. Pay attention. From A, I'm going to draw a perpendicular onto DC. Yes, draw altitudes. That's correct now. And from B as well, I will draw a perpendicular to the same side CD. Students, pay attention. I have drawn two altitudes onto DC from A and B. So pay attention. This is what we are going to do. Draw AN perpendicular to DC and draw BN perpendicular to DC. In that way, neither angle D nor angle C are getting divided into any parts. Now quickly look at these two triangles and quickly tell me, how are the two triangles gonna be congruent? How can I prove them congruent, students? Pay attention. Two things are extremely obvious. There's just one thing where you need to slightly use your concepts. Come on, quickly give me those three criterion by which these two triangles will be congruent? Yes, students, quick. There are two extremely obvious things, and there's one thing where you need to slightly use your concepts. Come on, quick. Yes, students? RHS. Okay, Swaraj says RHS. Swaraj, can you quickly tell me which sites are congruent? RHS. Okay, so everyone feels it's the RHS test. All right, quickly tell me which sides are congruent, students. I know there are two right angles. Okay, which other two pairs of sides are we looking at? Okay, Yugan says RHS as well. Swaraj says AM and BN. Yes, Swaraj, why are AM and BN equal? Yes, AM and BN. Even others, why are AM and BN equal? Are they equal? Are they really equal? Is that given to us? Okay, AB parallel to CD. All right. AD and BC. Yes, yes, Yugant. AD and BC are the hypotenuse, and it's given that they are equal. That's correct. Yes, Swaraj. AB is parallel to CD. So, आगे? Yes, what happens if we have two sides parallel to each other? All right. Okay. Students, pay attention. AB and CD are parallel to each other. And yes, parallel sides, the distance between two parallel lines is always constant. Point to be noted, perpendicular distance between two parallel lines is always constant. And AM and BN are the perpendiculars between two parallel lines. So from our construction, AM is always equal to BN. Yes, that's your third pair of corresponding sides. Yes, you have one pair of angles equal, hypotenuse are given to be equal, and AM equal to BN because it's the perpendicular distance between two parallel sides, and that is equal. So that's correct, students. The two triangles are congruent by the RHS rule, and as soon as you get that, this entire thing was done to get C and D congruent, right? So C and D are corresponding angles of congruent triangles. You can write CACT or CPCT, corresponding angles of congruent triangles. Now, is that understood, students? Quickly, let's move to the other thing now. So let's look at A equal to B. Now we want angle A equal to B. But in this case, if you look at our altitudes, they divide A and B. So we definitely cannot use these triangles or these altitudes to prove A and B congruent. So let's see what else we can do, students. Pay attention. There are a lot of ways to prove this, but let's look at the easiest way since we already have C equal to D. Students, now pay attention. One thing, C is equal to D given. Yes. Now look at this. AB is parallel to CD. So I have AB parallel to CD. And look at transversal AD. On transversal AD, what can I say about angle A and angle D? Yes, students, what can I say about angle A and angle D? So AB is parallel to CD, and on transversal AD, what kind of angles are angle A and D? Yes, students, between two parallel lines, only three options. Alternate, corresponding, co-interior. So what kind of angles do you think A and D are? Okay, Swaraj says co-interior angles. All right. Paka? Others who feel no, maybe they are corresponding, no, maybe they are alternate. Yes, anyone else? Or all of y'all agree they are co-interior angles? All right. So definitely, students, these are a pair of co-interior angles, and co-interior angles form a letter C, right? So these are the angles within the letter C. So definitely they are co-interior angles. And what do we know? Angle D, I don't really understand this. What do you mean by this, Swaraj? What do we know about co-interior angles? What's the relation between co-interior angles? Angle D equal to angle A. All right. So, okay, Swaraj says angle D equal to angle A, and so does Gandhar. All right. What about others? Angle A and D are equal? Yes? No? Yes, Swaraj. That's correct now. Angle A and angle D are not equal. Co-interior angles are always supplementary. Students, you have only one pair of angles which are supplementary, which are co-interior angles. Alternate angles and corresponding angles are equal. So I know now A plus D is equal to 180 degrees. Similarly, look at AB parallel to CD and now on transversal BC. Now we are looking at transversal BC, and the same way, angle B and angle C are also co-interior angles. Angle B and angle C are also co-interior angles. So now if you observe, students, since the right hand sides are equal, can I safely say A plus D is equal to B plus C? Yes, always when the right hand sides are equal, left hand sides have to be equal. A plus D is equal to B plus C. But we had just now proved that C and D are equal. So can I strike out C and D? Since they are equal, C and D will cancel each other because they are on opposite sides of the equal to sign. And what remains? A equal to B. Yes, this is what remains. Since we have A plus D equal to 180, B plus C equal to 180, we have equated them, and D and C cancel each other. What remains is A equal to B. We have just got what we wanted. A equal to B. Yes, is that okay, students? All right. Now, if you had to prove A equal to D, was there another way? So I'm just going to take this behind. And is there another way to prove A and B equal to each other? Students, pay attention. If I draw diagonal AC, yes, if I draw diagonal AC, I have triangle ABC in which we have angle B. Yes, we have entire angle B. And I'm also going to draw diagonal BD. Yes, so if I draw diagonal BD, look at triangle DAB. Triangle DAB. Yes, triangle DAB has entire angle A. So if I prove these two triangles congruent, my work will be done, right? A and B will be congruent to each other. This is just an alternate way to solve the same sum for A and B. Yes, now come on, quickly look at triangle ABC. It is this triangle, yes, and triangle DAB, which is this other half of the triangle. Quickly tell me, how can you prove these two triangles congruent? Come on, students, observe. Extremely easy. Everything is right out there. What do we know? Can I prove these triangles congruent? Yes? Come on, at least using the existing information. Okay, Yugan says SAS test. All right. Yes. Yes, that's so evident, right? AB is the common side. AD and BC are equal to each other. That's given. And we had just now proved, yes, that angle A and angle B are congruent to each other. We have just now proved that thing. So now I can say that the two triangles are congruent to each other. And if the two triangles are congruent to each other, students, pay attention. Look at the fourth part. ABC and BAD. Yes, ABC and BAD, once they are congruent to each other by SAS test, we need diagonal AC equal to diagonal BD. Diagonal AC, that is the first and the third letter, corresponds to the first and the third letter of the second triangle. So diagonal AC is definitely congruent to diagonal BD by CPCT. Since whenever you have such sums where you prove two triangles congruent and when you need two sides equal, check if those two sides belong to the two triangles that are congruent. If they are sides of those two triangles, definitely by CSCT or CACT, the two triangles will, the two sides or angles will be congruent to each other. Is this understood? So we have just now finished the third and the fourth part simultaneously. We have taken the third and the fourth part simultaneously. Let's quickly observe. All right, so we have quickly proven these two triangles congruent by SAS test and AC equal to BD by CPCT. Anyone, any doubts with anything in this sum? Anything related to this sum? All right, no, okay. All right. Okay, students, so let's quickly move ahead now. Now, we move to the most important theorem of this chapter. The most important theorem, also known as the midpoint theorem. And this theorem is going to be used even in your 10th standard, so you cannot forget this theorem. We're going to first look at this theorem and we'll prove this theorem in the later slides. Now, some important things that you need to note about this midpoint theorem. The midpoint theorem only applies to a triangle. Yes, so I understand we're doing the quadrilaterals chapter, but this theorem is about triangles. So the midpoint theorem can be applied only to the triangles. Now, as the name suggests, midpoint, right? So when you say midpoint, there should be some midpoints. Midpoints of what? Of the sides of the triangle. So we have midpoints of sides of the triangle. Now let's quickly observe what this midpoint theorem says. In a triangle, line segment joining midpoints of any two sides. Forget the line segment or anything. What we have is we have a triangle and we have midpoints of any two sides. Can I take those two sides as AB and BC? So I'm just going to select my two sides as AB and BC. So can I say that midpoint of AB is say P, and I'm going to select my second side as AC. So midpoint of AC is Q. Now what does it say? Line segment joining the midpoints. That means we need to join these two midpoints. So I have joined the midpoints. Now, if this happens in a triangle, if there is a line segment joining midpoints of any two sides of a triangle, then what do we know about such a triangle? That this line segment PQ is parallel to the third side. Students, which is the third side? It's the side which we have not considered for midpoints. That means it cannot be AB and it cannot be AC. That means the third side we are talking about is BC. And what we understand is the line segment is parallel to this third side, and the line segment is also half of the third side. So what we understand is PQ parallel to BC and PQ is half of BC. Let's again look at this. What does this mean? Let's go through this theorem again, since this is an extremely important theorem. In a triangle, again I repeat, midpoint theorem only applies to a triangle. So whenever there are sums given, if there are midpoints of any sides and there's a triangle that can be formed, you can always apply this theorem. All right, okay, so quickly let's look at this and then we'll stop here and we'll look at the sums related to this theorem in the next lecture. All right, so again I repeat, we have two sides AB and AC which we have selected, and we have taken P and Q as midpoints of these two sides. P is the midpoint of AB, Q is the midpoint of AC. So the remaining third side is parallel to this segment PQ, and remaining side is parallel to PQ, and PQ will also be half of this third side. So these are the two important results of the midpoint theorem, which you will always get if in a triangle you have midpoints of two sides of a triangle. So all right, students, we stop here for today. I'll see you all in the next lecture. Hopefully in the next lecture, kindly revise your properties once again. I'm sure you all have revised that, and revise the midpoint theorem as well. The rest of the sums of this chapter will be solved only using midpoint theorem now. All right, so henceforth we will only be using the midpoint theorem. All right, students, so I'll see you all the next time. I hope you enjoyed the lecture and learned something. So I hope this was a good lecture. All right, thank you so much, students. All right, I'll see you all in the next lecture. Okay, with your homework done. Okay, so bye-bye. Yeah, thank you so much. Yeah, all right, see you all the next time. Yeah, okay.